sound is audible. I think now the sound is audible, no problem. So I have not seen that Jack was not inserted, no problem. Now it is live and you can see, you can hear my voice clearly. So I think now it is audible, no problem. So here yesterday we have left with two more problems. Yesterday we have left with two more problems, that is problem number 7 and problem number 8. So I will finish these two chapters and next we can go for the local maximum and local minimum values. Okay. So all of you are safe. I think all of you are safe, healthy and well-being. No problem. Be safe and be at home. Okay. Be at home and study. How much you do study, that much you are going to score in your exam. No problem. Now let us go for the 7th one. Now let us go for the 7th one. That is a ladder 5 meter long leaning against a wall. Okay. So let us consider this is the wall and this is the ladder leaning against a wall and this is ground. The bottom of the ladder is pulled along the ground away from the wall. That means from here it is pulled along the ground away from the wall at the rate of 2 centimeters per second. So let us take this is y and let us take this is x, and it is pulled at the rate of dx by dt, which is equal to 2 centimeters per second. Now how fast is its height on the wall decreasing? The foot of the ladder is 4 meter away from the wall. That means whenever x value is 4, that is 4 meter away from the wall, what will be the decrease? That means the rate of change of wall. That means the height of the wall, rate of change of the height of the wall is what they are asking. Clear? Okay. So that means we have to answer with the rate of change of height of the wall. No problem, that we have taken it as y and we have taken it as x. So here you can just see this is right angle triangle. So from a very simple problem, that is x square plus y square, let us take this is the length of the ladder, that is L square. So x square plus y square is equal to L square. Now we have to calculate the rate of change of y. So that's why I take this as y square equal to L square minus x square. So now here we can differentiate on the both side. That will be 2y into dy by dt, or before differentiate we solve one more step, that is apply square root on both side. Apply square root on both side, that will be y equal to root of L square minus x square. Clear? So now if I differentiate this, it will be dy by dx equal to, we know that the differentiation of root x is 1 by 2 root x. You apply the same for root of f of x. So that will be also the same, that is 1 by 2 into root of f of x multiplied with f dash of x. Okay. That will be 1 by 2 root of L square minus x square into, again the differentiation of L square minus x square is minus 2x. Okay. So now 2 you can cancel. The remaining term is going to be rate of change. That means we are differentiating with respect to time. Rate of change, that means we are differentiating with respect to time. So here you have to differentiate it with respect to time. Be careful. Here we have to differentiate with respect to time. That will be multiplied with dx by dt. Okay. So now dy by dt equal to 2 has been cancelled, minus x divided by root of L square minus x square multiplied with dx by dt, multiplied with dx by dt. Okay, so here you can just see the length of the ladder is 5 meters, and now you can calculate from this, and the x value is 4. They have given x value is equal to 4 meters, so that you can use here. Therefore dy by dt equal to minus 4 divided by, here you can see L square, that is 25. 25 minus 4 square, that is 16, into dx by dt, that is 2. So if you simplify this, it will be minus 8 divided by 25 minus 16 is 9, and root 9 is 3. Okay. So this will be the answer, minus 8 centimeter per second. Minus 8 centimeter per second. Okay. So that means minus 8 by 3 centimeter per second. Clear? So while doing the differentiation, be careful. You have to differentiate with respect to time. That is very, very important. And this was the matter which we have discussed yesterday, that I can't remove because it is already saved in the file. So no problem. Now you got the answer. The rate of change of decrease in the height of the wall is minus 8 by 3 centimeter per second. Now let us go for the 8th problem. That is, a man of 2-meter heights walks at a uniform speed of 5 kilometers per hour away from the lamp post, which is 6 meters height. Okay, so this is 6 meters height lamp post, and let us take, this is the ground, and let us join these 2 points. Now the height of the man is 2 meters. The height of the man is 2 meters. He is walking away from the lamp post at the speed of 5 kilometers per hour. At the speed of 5 kilometers per hour. So now you can just see, I will take this as A, B, C, D, E. So here from the diagram you can see that the triangle ABC is congruent to triangle ADC. Okay, triangle ABC is congruent to triangle ADE. Clear? So from that you can just see BC divided by DE will be equal to AC divided by AD. AC divided by AD. So now CD length I will take it as X, DA length I will take it as Y. DA length I will take it as Y. Now you have to calculate, find the rate at which the length of the shadow is increasing. That means shadow will be present here. Now you have to calculate the rate of change of Y. Shadow will be present here, so that you have to calculate rate of change of Y. So BC by DE is 6 by 2 equal to AC, the length of AC will be what? X plus Y divided by, you can see the length of AD is what? Y. I have taken it as Y. So now 6 by 2 is 3 will be equal to X by Y plus 1. So this will be 2 equal to X by Y. Therefore you can write it as X equal to 2Y. You can write it as X equal to 2Y. Now rate of change of X with respect to Y, that is dx by dt will be equal to 2 into dy by dt. 2 into dy by dt. So dy by dt is given as 5 kilometers per hour. So that you can take it as 5 kilometers per hour, no problem. So therefore here you are going to get it as dy by dt is 5 kilometers per hour. So you got 3 minus 1 is 2, so 2y equal to x. So dx by dt is 2 dy by dt, and now you can see dy by dt will be equal to 1 by 2 into dx by dt. 1 by 2 into dx by dt. And they have given he is walking at 5 kilometers per hour, so that dx by dt is going to be equal to 5. So therefore, here you can see dx by dt is 5. You can write here the given term is dx by dt. That means if he walks away from the lamp post, the rate of change of x is calculated with 5 kilometers per hour. Okay. So with that you can see it will be 5 by 2 kilometers per hour. 5 by 2 kilometers per hour. This will be your answer. Problem is very simple. Just you have to think and you have to solve. So quickly tell me, all of you, have you understood this? Quickly tell me, all of you, have you understood this? That is 5 kilometers per hour. Okay. So most of the students are not attending the class. No problem. Very good. Let them enjoy their life. We shall not disturb them. Disturbing others is not good. Okay. So we shall not disturb them. So give me thumbs if you have understood this. So quickly we can go for our next problem, that is of local maximum and local minimum. Local maximum as well as local minimum. So of this local maximum and local minimum, what you have to do? They will give you f of x. From this you have to calculate dy by dx. Is nothing but dy by dx will be equal to f dash of x, and you have to equate this term to 0. After that you have to calculate d square y by dx square, and what you have to do? Here you find the values of x, that be alpha and beta, no problem. So now you will get d square y by dx square. In this d square y by dx square you have to calculate f double dash of alpha or f double dash of beta. So if f double dash of alpha is lesser than or equal to 0, it is local maximum. It is local maximum. And if f double dash of beta is lesser than, greater than or equal to 0, then it is local minimum. Then it is local minimum. So this is what you have to solve. If the double differentiation is lesser than 0, local maximum exists. If the double derivative is lesser than 0, local maximum exists. If the double differentiation is greater than 0, it will be existing with minimum. That means they will give you function. You have to calculate dy by dx, that is nothing but f dash of x. Equate this term to 0. After equating to 0, you find the values of x of this f dash of x. So x will be either alpha or beta. That means you are going to get the values of x. After that, you just take them in box and differentiate this equation again. You will get d square y by dx square. So now here you are going to get f double dash of x. Now you have to put the values of x. To take f double dash of alpha, if it is greater than or equal to 0, it is local minimum. It is local minimum. Okay. So f double dash of alpha is lesser than or equal to 0. It is local maximum. It is local maximum. Okay. So this is the rule for local minimum and local maximum. Clear? Okay. So in the previous problem you can just see there is a man of 2 meters height. There is a 6 meter height pole. This man is walking away from the lamp post. That means this x is increasing. The rate of change of x is given. The rate of change of x is given as 5 kilometers per hour. Now they are asking how this shadow is increasing. See, there is a man, there is a lamp. Now this is the x. He is walking away from the lamp post. That means the rate of change of x is dx by dt is given as 5 kilometers per hour. Now here if the light falls, this is the shadow, it is increasing. That means if I take this as y, we have to calculate dy by dt. Okay, so the further calculations are very simple. This is 2, this is 6. Here there are two triangles, so they are congruent. So BC divided by DE will be equal to complete AC divided by AD. You take that, 6 by 2 will be equal to AC means x plus y divided by AD means it is y. So x 6 by 2 is 3. 3 will be equal to x by y. If you separate the terms, x by y by y is 1. Take plus 1 on this side, it will be 2 equal to x by y. Calculate it, x equal to 2y, differentiate it, put the value, you will get the answer. Okay. Now coming to local maximum and local minimum. Just see how to simplify the first problem. Solution. So they are asking the local maximum. G of x is given as x cube minus 3x. G of x is given as x cube minus 3x. Calculate g dash of x, that is 3x square minus 3, and equate this to 0. Equate this to 0, that will be g dash of x equal to 0. Okay, so now 3x square minus 3 will be equal to 0. 3x square equal to 3. X square will be equal to 1. And x will be equal to plus or minus 1. X will be equal to plus or minus 1. Okay. So now again I has to take the double derivative from this g dash of x. What is g dash of x? 3x square minus 3. If I calculate z double dash, see, you differentiate it again, it will be 6x. Okay. So now I have to check for which value it is lesser than 0, because I want maximum value. If I take x value as minus 1, 6 into minus 1, that is minus 6. That means c double dash of x is lesser than or equal to 0 at x equal to minus 1. Therefore, local maximum exists at x equal to minus 1. But remember, this is not maximum value. So maximum value, if you want, maximum value is g of minus 1. Okay, you have to put this minus 1 in g. So g of minus 1, that is minus 1 cube minus 3 into minus 1. It will be minus 1 plus 3, it will be 2. So local maximum value is 2. Local maximum value is 2. Okay. So like this you have to calculate. Clear? First differentiate once, equate to 0, find the value of x. First equate the term. First differentiate, equate it to equal to 0. Next find the value of x. So keep it in box. Double differentiate, you will get 6x. Now they are asking local maximum value. So you check at which point it is going to be lesser than or equal to 0. So put that term and you have to say that local maximum exists at x equal to minus 1. But that is not local maximum. If you want to get local maximum, you have to take it in g of x. You have to take it in g of x and put it in g of x. There you are going to get the value 2. So this is local maximum value. So what about x is equal to plus 1 means, you see, if you put x is equal to plus 1 here, what happens? G double dash of x will be going to be greater than or equal to 0. Okay, why? Because 6 into 1 is 6. So it is going to be greater than or equal to 0. Here local minimum exists. Local minimum exists at x equal to 1. So if they ask local minimum, you take this x equal to 1 and you put in g of x. Okay, you can take this x equal to 1 and you can put in g of x, so that you will get local minimum value. You can check that also. That will be g of 1. So 1 cube minus 3 into 1. So see that it will be minus 2. This is local minimum and see this is local maximum. Okay. So according to the demand of the problem, you have to simplify. If they ask both, you solve the both. If they ask any one of this, you can solve it any one, no problem. Clear? So now I think you have understood this. So that give me quickly the thumbs or the big smiles if you have understood. I can go for the next problem. Okay. Okay, now I will go for the second problem. You just see, find the local maximum and local minimum value. That means they are asking both. So for that we shall calculate the both terms. F of x will be equal to x cube minus 3x plus 3. X cube minus 3x plus 3. So differentiate once, you are going to get 3x square minus 3. So now f dash of x is equal to 0. F dash of x is equal to 0. That means 3x square minus 3 will be equal to 0. So from this you can just see, again 3x square equal to 3, x square equal to 1, x square equal to 1, and x is equal to plus or minus 1. X square is equal to 1 and x will be equal to plus or minus 1. Okay. So now here you can calculate f double dash of x. That will be again 6x. Clear? So previously we have solved this. So it will be going to very easy. Put x equal to 1. Put x equal to minus 1. So f double dash of x is equal to 6. At x equal to 1, that means it is greater than 0. That means it is greater than 0. Okay. So f double dash of 1, you can see that f double dash of 1, that is 6 into 1, is greater than or equal to 0 at x equal to 1. That is local minimum exists. Local minimum exists. Okay. And put x equal to minus 1. F double dash of minus 1 will be 6 into minus 1. That is f double dash of minus 1. F double dash of x is lesser than or equal to 0 at x equal to minus 1. Local maximum exists. Local maximum exists. Okay. At x equal to minus 1. Here at x equal to 1. So therefore, f of 1 is 1 cube minus 3 into 1 plus 3. This will be how much? 1 minus 3. Minus 3 plus 3 will get cancelled. This will be 1. So here f of minus 1, that will be minus 1 cube minus 3 into minus 1 plus 3. That will be plus 3 plus 3, 6. 6 minus 1 is 5. Okay. This is maximum value. Therefore, local maximum value is 5 and local minimum value is 1. Local maximum value is 5 and local minimum value is 1. Clear? So here roots are going to be same for the previous problem, but the local maximum and local minimum are going to be changed because of this plus 3. Okay. So see there in the problem, they have just given one extra term. Here this plus 3 and that plus 3 is not present here. Okay. So no problem. Because of plus 3, you are going to get this different local minimum and local maximum. No problem. Very simple question. You can do it. Okay, now let us go for the third problem, and it was like a same previous problem, only one term 3 is different, that's all. So let us go for the third one. What is the third one? Find the two positive numbers. See the third one. Find the two positive numbers whose sum is 15. Whose sum is 15 and sum of whose square is minimum. And sum of whose square is minimum. Okay, no problem. So here you can just see they have given two positive numbers. Let x and y. Let x and y be two positive numbers. Two positive numbers. So from that you can say x plus y is equal to 15, and you can say square of them x square plus y square equal to z. So that they have given that it is minimum. Let us see. Now y will be equal to what? 15 minus x. So I can use it in second equation. Take this as 1, take this as 2, use this term in second equation. So x square plus 15 minus x whole square equal to z. So now if you differentiate this, it will be 2x plus 2 into 15 minus x into minus 1 equal to dz by dx. From this you can just see we have to equate it equal to 0. So that will be nothing but 2x minus 2, 15 times of minus x going to be equal to 0. If you simplify this, x will be equal to you can say 30 minus x. So 2x is equal to 30 and x is going to be equal to x is going to be equal to 15. Clear? So check once it is correct or not. So here it is going to be minus 2 into minus 15 minus 30. This side it will be plus 30, minus into minus plus. Okay, let us solve it because it is little bit confusing at this step. Let us solve it again, no problem. So 2x, see here, this is 2x equal to minus 30. If it comes on this side, it will be plus 30. Minus into minus, it is plus. If it comes on this side, it will be minus 2x. Okay, so that will be 4x equal to 30. So very good. Now you can just see that x will be equal to 30 by 4, that is 15 by 2. So x will be equal to 15 by 2, no problem. Now you have to go for double differentiation, d square z by dx square. If I solve it once again, if I differentiate it once again, see this equation, it will be 2 minus into 2 is, that is minus 2, no problem, minus 2. But here if I differentiate this, minus 2 differentiation of 15 is 0 and the differentiation of minus x is minus 1. Minus 1 minus into minus will be plus, so that is 4. You can see that d square z by dx square is going to be greater than or equal to 0. Therefore local minimum exists. Local minimum exists. Okay, so be careful while solving the double differentiation. If you get any doubts, you can see here again. Here dz by dx is 2x, minus into 2 is minus 2, 15 minus x. So you can see that 2x minus 30 and minus into minus will be plus 2x. Minus into minus will be plus 2x. So you differentiate it again. If you differentiate it again, what you are going to get? D square z by dx square. Differentiation of 2x is 2. Differentiation of 2x is 2. That will be 4. Differentiation of minus 30 is 0. D square z by dx square is going to be equal to 4. That you got here. Okay. So I have explained that second derivative one more time because you may get confused. No problem. So d square z by dx square is 4. that is greater than or equal to 0, local minimum exists. Okay, local minimum exists at 15 by 2. Now y equal to how much? 15 minus 15 by 2. Y will be also equal to 15 by 2. Therefore, your required answer is 15 by 2 comma 15 by 2. So this is your value for x and y. Quickly, all of you tell me, have you understood this? Quickly, all of you tell me, have you understood this? Very simple problem and very important problem. If you have understood, no problem. We can go for the next one. If you have any doubts, please tell me. I can solve it again and I can clarify your doubts. Okay. Very good. So all of you are replying with yes. So that means I can go with the fourth problem, that is find the two positive numbers whose sum is 16. Same, x plus y equal to 16, and sum of whose cubes. They have given that sum of cubes is minimum. That means x cube plus y cube equal to z. No problem. Y is going to be equal to 16 minus x. That you can write here. Y is 16 minus x whole cube equal to z. Now we have to differentiate. Take the first equation, take the second equation, differentiate the second equation. This will be 3x square plus this will be 3 times of 16 minus x whole square into minus 1, because differentiation of 16 minus x is minus 1, will be equal to dz by dx. Okay. So again, by differentiating this, first we shall find by equating this equal to 0. What you are going to get? 3x square will be equal to 3 times of 16 minus x whole square. 3 will get cancelled. X will be equal to 16 minus x. 2x will be equal to 16. This implies x equal to 8. Clear? Okay. No problem. Now let us go for double differentiation. D square z by dx square. If I double differentiate it, it will be 6x. So here you can see minus into plus will be minus. Okay. So minus 3, already you have minus into plus is minus 3. Again 16 minus x whole square. So it will be 2 into 16 minus x, and again differentiation of 16 minus x is minus 1. Again differentiation of 16 minus x is minus 1. Okay. So that will be 6x. Minus into minus will be plus 6 times of 16 minus x. Okay. This is your double derivative. That means f double dash of x, that is 6x plus 6 into 16 minus x. So now you got x is equal to 8. So that you have to put here and you have to check the term. 6 into 8 plus 6, 16 minus 8. So you can just see 6 into 8 is 48 plus. Here also you are going to get 48. 48 plus 48 is 96. 48 plus 48 is 96. So which is greater than or equal to 0? Which is greater than or equal to 0. Therefore, local minimum exist. Local minimum exist at x equal to 8. Local minimum exist at x equal to 8. So therefore, y will be equal to 16 minus 8. So y will be equal to 8. Therefore, your required answers are 8, 8. Your required answer is 8, 8. Clear? So quickly tell me, all of you, have you understood this? So quickly tell me, all of you, have you understood this? Okay, you see the double derivative once again. You see the double derivative once again. you have the equation x cube plus y cube equal to z, right? So first I will differentiate this. What you will get? Dz by dx equal to 3x square plus, in the place of y what you have? Z equal to x cube plus 16 minus x whole cube. Okay, no problem. So if I differentiate this, it will be 3 into 16 minus x whole square, because here you have to use x to the power of n formula. So that is n into x to the power of n minus 1. But here again you have 16 minus x, that you have to differentiate again. You have to apply chain rule for this. By applying chain rule, it will be 3 into 16 minus x whole square into d by dx of 16 minus x. So that will be 3x square. Differentiation of 16 is 0. Differentiation of minus x is minus 1. Minus into plus is minus 3. 16 minus x whole square. So now you have to differentiate again. D square z by dx square. That is 6x. Here you can just see again 16 minus x whole square you have to differentiate. Apply x to the power of n formula. Minus 3 constant, it will be 2 into 16 minus x. 2 minus 1 is 1. But again d by dx of 16 minus x. So here this will be minus 1. So 6x minus into minus will be plus. Clear? So plus 6 into 16 minus x. This will be your answer for the double derivative. So I think you have understood the double differentiation. No problem. If you have any doubts, you can go through the video again and again, because I have already explained twice. So you can understand it, no problem. Okay. So quickly tell me, Jayed and another one who have said that double differentiation. About the double differentiation, they have asked the question. So I have explained it. So no problem, you can understand it. Clear? Okay. So now you see the fifth question. Now you see the fifth question, that is, find the two numbers whose sum is 24 and the product is as large as possible. So here you can just see the fifth problem. Find the two numbers whose sum is 24, x plus y equal to 24, and the product is as large as possible. That means x into y equal to z. Y will be equal to 24 minus x. So you take this as equation 1, you take this as equation 2. In the place of y, I have to write 24 minus x equal to z. Clear? So this will be 24x minus x square equal to z. So if I differentiate it, it will be dz by dx equal to, differentiation of 24x is 24, differentiation of x square is 2x. No problem. So you check here, I will do double differentiation here only. Differentiation of 24 will be 0. Differentiation of minus 2x will be minus 2. So therefore equate 24 minus 2x equal to 0. So that therefore 24 will be equal to 2x, x will be equal to 12. And here you can see double derivative is lesser than or equal to 0. Therefore local maximum exists. Therefore local maximum exists. Clear? So therefore from this you can see, therefore y will be equal to 24 minus 12, because see here x is equal to 12, y is also equal to 12. Therefore 12 comma 12 is the required term. Therefore you can see 12 comma 12 will be the required value. So all of you quickly reply me, have you understood this? If you have understood, quickly give me thumbs or big smiles so that I can go for the next problem. Clear? Quickly reply me. If you have any doubts, you can ask, no problem. And the sixth one is, find two positive numbers whose product is 100. Very good. So here they are telling find the two positive numbers whose product is 100. That means see here I can take x into 100 by x. That will be equal to 100. X I will cancel. It will be equal to 100. Okay. So they have given find the two positive numbers whose product is 100. Clear? That's why I will take it as x into 100 by x. Because the product must be 100. Because the product must be 100. Clear? Otherwise, you can also take it as x plus x into y equal to 100. Y will be equal to so term, that you can simplify. No problem. Okay. Let the two numbers be x and 100 by x. Because such that the product is 100. And next they have given that whose sum is minimum. That you can just see z will be equal to whose sum is minimum. That means x plus 100 by x. And the sum of whose sum is 100 is 100, whose sum is minimum. That means x plus 100 by x. That is the sum is minimum. So now you can differentiate it. Dz by dx will be equal to differentiation of x is 1. And here 100 you have, no problem. Differentiation of 1 by x. Differentiation of 1 by x is minus 1 by x square. Differentiation of 1 by x is minus 1 by x square. Okay. Again you have to differentiate it. You will get d square z by dx square. Differentiation of 1 is 0. Minus as it is. 100 as it is. Differentiation of 1 by x square is minus 2 divided by x to the power of 2 plus 1 is 3. Therefore 200 divided by x cube. So here you can see the double derivative is 200 by x cube. And if I equate this term to 0, dz by dx equal to 0, you will get 1 by 100 minus x square equal to 0. Take LCM and simplify. It will be x square minus 100 equal to 0. X will be equal to plus or minus 10. Take here LCM and simplify. X square minus 100 divided by x square will be equal to 0. So x square minus 100 divided by x square equal to 0 means you can take x square into 0 will be 0. X square minus 100 equal to 0. X will be equal to plus or minus 10. Now you can choose either x equal to 10 or x equal to minus 10. But what they are telling, the sum is minimum. That means it should be greater than or equal to 0. If the double derivative is greater than or equal to 0, then the sum will be minimum. So therefore d square z by dx square is greater than or equal to 0 at x equal to 10. So if I put x equal to 10, it will be positive. If I put x equal to 10, it will be positive and it will be greater than or equal to 0. Okay, because you will get 200 divided by 10 cube. This complete term will be positive. Whatever it may be, it will be positive. So therefore it is positive at x equal to 10. So therefore local minimum exists. Local minimum exists. Local minimum exists. Okay. Therefore, what about y? Another term you can see there that x into 100 by x. Okay. You can just see if I multiply both the terms, you must get 100. Clear? So if I put in the second term, that is 100 by x. You can see 100 by x. X is 10. So again you can see here if I put x value as 10, 100 by 10, that will be 10. Therefore 10 comma 10 is your point. You can just see x is equal to 10. If I multiply it with another number, that is x into 100 by x is equal to 100. Okay. So for that, you now x is equal to 10. You can take this term, put x is equal to 10. Therefore, you can simplify it. you can get the answer. That will be x equal to 10. Clear? So both the terms are 10. If you get confused, what you have to do, you just see. If you get confused here, because some of you can get confused here, for that what you do? You do here one thing, that is, you take the first term as x and the next term as y, x and y. Okay, here y will be equal to what? 100 by x. Okay, you take x and y, so y will be equal to what? 100 by x. You take this as x, you take this as y. So now y will be equal to what? 100 by x. X is 10. 10, if you simplify, this will be equal to 10. Therefore 10 comma 10 is your required answer. 10 comma 10 is your required answer. Okay, so if you get confused, you can solve like that. First term you take x, next term you can take 100 by x, so that is y. You put the second term as y, that is 100 by x. Clear? So now if you want to simplify y will be equal to 100 by x. Take x value as 10, therefore y will be also 10. Therefore 10 comma 10 is your answer. Clear? So shall I go for the 7th problem or 8th problem? I have to solve both, or I have to solve directly 8th one? Will you solve the 7th one? How many of you can solve the 7th one? Is there anyone to tell me that solve both? If you say go for both, I will go for both. If you say sir directly solve the 8th one, I will solve the 8th one. Quickly tell me. Always you tell to solve every problem for me only. No problem. See the 7th one. Okay, see the 7th one. Find the two positive numbers. Find the two positive numbers, that is x and y, such that x plus y is equal to 60 and x y cube is maximum. So that I will take it as z. So you take this question as 1, you take this question as 2. Okay. So now you see here, I will write x term as 60 minus y, because if I write y equal to 60 minus x, what happens if I write y equal to 60 minus x? I has to put this in second equation. It will become x into 60 minus x whole cube, which will take long. Otherwise it takes one more extra step. So to reduce that, what I will do, I will write x is equal to 60 minus y. So in the place of x I can write 60 minus y. In the place of y it be y cube equal to z. No problem. Now z will be equal to 6 y cube minus y is minus y cube. And you can see y cube plus 60 is plus 60 y cube. This is y raised to 4. Clear? Y cube into y is y raised to 4. Okay. This is y raised to 4 and this is plus 60 y cube. Now we have to differentiate with respect to y. No problem. Minus 4 y cube plus 180 y square. You have to differentiate it again. So if you differentiate it again, minus 12 y square plus 360 y. Okay. So now equate this term to 0. Minus 4 y cube plus 180 y square will be equal to 0. 180 y square equal to 4 y cube. Cancel y square and y cube. So you can simplify. Y is equal to 180 by 4. So if I simplify this, it will be 45. Okay. So now you got y equal to 45. You put this y equal to 45 here. D square z by dy square. minus 12, 45 square plus 360 into 45. Quickly simplify this and check it is greater than 0 or not. Okay, you have to check this, it is greater than 0 or not, because if it is greater than 0 then only, sorry, if it is lesser than 0 then only maximum exists. Okay, so let us check this. How much? That is 45 square, 45 square multiplied with 12, it will be 24,000, will be 24,300, is minus 24,300, minus 24,300 plus 360 into 45, 360 into 45 that is 16,200, 16,200. So you can check that d square z by dy square is equal to lesser than or is equal to 0, lesser than or is equal to 0, therefore local maximum exists, local maximum exists. Because they have given local maximum exists, you have to satisfy that, you have to satisfy that. Clear? So if local maximum exists, you can just say x will be equal to 60 minus 45, because y is equal to 45, x will be equal to 15, therefore 15 comma 45 is your required answer. Okay, so we can see 15 comma 45 will be your answer, 15 comma 45 will be your answer. Clear? Okay, so now we can go for the last problem. You can go for the last problem, that is 8th one. Clear? Okay, so you just simplify 45 square into minus 12, 45 square minus 12, sorry, 45 into 45 will be 2,205 into 12, sorry, into 12, 24,300. Okay, minus 24,300 minus 24,300 plus 16,200. You just simplify. Okay, what is your answer? Minus 24,300 plus 16,200, it will be 0, 0, 1. It says if I go for this 14 minus 6, 8 minus 8100. Okay, minus 8100. Someone have written minus 81000. That's why I got confused. Clear? Be clear about it. Okay. Now we can go for the 8th problem. Now we can go for the 8th problem, that is find the absolute maximum and absolute minimum. That is nothing but same again, local maximum and local minimum logics. F of x is given as sin x plus cos x. So now you can just differentiate it. You will get f dash of x, that is cos x minus sin x. Okay, f dash of x is cos x minus sin x. F double dash of x is minus sin x minus cos x. Equate f dash of x equal to 0. So that will be cos x minus sin x equal to 0. So now you can see cos x will be equal to sin x. Cos x will be equal to sin x. This implies it is only possible for x is equal to pi by 4. And they have given the interval x belongs to 0 comma pi. So in this interval there is only one term, that is x equal to pi by 4. So for x equal to pi by 4, it is possible. That is x equal to, sin x is equal to cos x. Therefore, f double dash of x, in that you can put pi by 4 and you can see minus sin pi by 4 minus cos pi by 4 minus 1 by root 2 minus 1 by root 2. Therefore, minus 2 by root 2 is nothing but minus root 2, lesser than or equal to 0. Local absolute maximum exists. Absolute maximum exists. Clear? You can see that absolute maximum exists and you can find the maximum value. Therefore, you can say absolute maximum exists. Maximum exists at pi by 4. Therefore, f of pi by 4 will be equal to sin pi by 4 plus cos pi by 4. That will be root 2. So root 2 is your maximum value. Root 2 is your maximum value. Clear? So from this you can see that root 2 is going to be your maximum value. Okay. So hence we are finally at the end of our application of differentiation. So please go through all these problems which are very useful, and you all can understand these problems. I have solved almost all important problems, and some of the problems may be missing from your online classes to offline and offline classes to online. That you can adjust with your notes, no problem. But quickly tell me about the next chapter, how you are doing, how you are doing with your notes preparation, as well as are you preparing or not, what about your CET, are you preparing for CET or not. You have to tell quickly. Okay, so I'll give 5 minutes of time. You can discuss me, and you can also tell me about the next chapter which we have to take, and you can also tell how many chapters we have covered. Just go and tell me how many chapters we have covered. I think differential equations is over, integration is over, this application of differentiation is over, differentiation chapter is over, relations functions is over, and LPP, you can also see LPP is also over, continuity is also over. Okay, next we are only remaining with application of integrals and matrices, determinants. Even 3D is also over. Even 3D is also over. Vectors is also over. Okay, so I think matrices, determinants, and we are remaining with application of integrals. Okay, we are remaining with only 3 chapters: application of integrals, matrices, and determinants. So I feel that matrices and determinants all of you can do on your own, no problems, and application of integrals I will do from tomorrow, so that you can go through it, and let us see. I will try to make chapter wise groups of the links of all your chapters, and I will share with all of you so that you can easily go through it. Already I have shared integration, differentiation, vectors, 3D, and I has to share now application of derivatives, differential equations. So I will do those links in one group so that you can see all the links together. Okay, that for you also it will be easy to refer. Clear? So very fine, thank you, and let us meet in the next session. Let us meet in the next session. Clear? Okay, take care yourself, and bye.